Our next concept is corrosion. When a metal is attacked by substances such as moisture, acids, etc., they get coated by certain layer. This process is called corrosion. This process is not good for metals. Corrosion makes metal weak and reduces their strength. Corrosion process for different metal is known differently. For example, iron's corrosion is known as rusting. Might be you have seen when iron articles are new, they are shiny. But as time passes, a reddish colored solid layer collects on their surface. This process is called rusting. Like that copper's utensil, you have seen that after few days or after exposure to moisture, copper is coated by green colored layer. That process is called patination. Silver articles becomes black after exposure to environment. So this corrosion process is making metals weak. Particularly now in this chapter we are going to focus on rusting of iron, that is corrosion of iron. Before seeing this point, just see next activity and from that just observe which nail rust fast.
Let us investigate the effect of external factors on rusting. We will need the following items for the experiment: nails containing iron, distilled water, sodium chloride, freshly boiled distilled water, edible oil, anhydrous calcium chloride, and test tubes with stoppers, a beaker, a funnel, a pipette, a spatula spoon, and a glass rod. We place nails in 4 test tubes. We add a little distilled water to the first test tube. We pour the water with some table salt into the second test tube. We add freshly boiled distilled water. It contains less dissolved gases from the air, and a little edible oil to the third test tube. The layer of oil will prevent the air in the test tube from dissolving in the water. We add calcium chloride, which will absorb the water vapor present in the air, to the 4th test tube. We seal the test tubes with stoppers and put the rack aside for a few days. If we examine the contents of the test tubes afterwards, we'll see certain changes. In the first and second test tubes, the nails were in contact with air and water, so they become covered in rust. However, no rust formed in the 3rd and 4th test tubes. In the 3rd test tube, the nail was in contact with water, but there was no access for air. In the 4th test tube, there was no water. It appears that air and water are needed for rusting to occur. Did adding salt have any effect on corrosion? Let us look once again. It turns out that the addition of salt accelerated the rusting. That is why the salt spread on streets in winter damages the bodies of cars.
So, during corrosion of iron, a reddish colored layer is collected on the surface of iron object. That process is called rusting, and chemically rust is written with the help of this formula Fe2O3.XH2O. X is variable. Rust on iron does not form by a simple reaction of oxygen with iron surface. The rust is formed by electrochemical reaction. Electrochemical, it is the combination of two words, electro and chemical. That is, charges are transferred from one place to other and reaction takes place. Different regions on surface of iron become anode and cathode. For example, consider this is the surface of iron object. This is water droplet and this is the rust get collected after reaction. Here some region of the surface acts as anode and some region acts as cathode. Now what is happening? At anode, iron is oxidized to form Fe2 plus ion. So as iron is converted into Fe plus ion, 2 electrons are released. Now at the cathode, oxygen gas is reduced to form water. Here you can see oxygen has combined with hydrogen, means oxygen is reduced. Now at the anode, whatever this Fe2 plus ions are formed, they migrate, means they starts to displace and they will travel towards cathode. At the cathode they react with water and they further oxidize to form Fe3 plus ion. That is, Fe2 plus ion is converted into Fe3 plus ion. After that, a reddish colored hydrated oxide is this Fe2O3 H2O is formed from Fe3 plus and water's reaction, and this is nothing but rust. This rust gets collected on the surface of iron object. Due to various components of atmosphere, oxidation of metal takes place, consequently resulting into their damage. This is called corrosion. Iron rusts and a reddish colored layer is collected on it. This is the corrosion of iron. Corrosion is a very serious problem because due to corrosion, strength of iron decreases. That's why we have to replace that iron object. That can be prevented by painting iron object, and if by that corrosion avoid is not possible, then we have to replace that iron material, which needs large amount of money. So we have to do expenditure in order to get rid of from corrosion.
Let's think about cars for a moment. The car that you've had in mind was likely painted with your favorite color. The paint is not only there to make your car look pretty, but it has a more important purpose, to prevent rusting. When iron and steel are exposed to oxygen and moisture, rusting will occur. Rusting describes the corrosion of iron and steel. The term corrosion is used to describe the breakdown of a metal when exposed to the environment. When we say a metal corrodes, we mean that it has reacted with water and oxygen from the environment to form their respective oxides. We can demonstrate this using a simple experiment. Place an iron nail in 4 test tubes. Fill one with regular tap water until the nail is submerged. Fill another with regular tap water and add half a spoonful of sodium chloride, regular table salt. Shake from side to side to ensure that sodium chloride fully dissolves. Fill the 3rd test tube with recently boiled water and add a thin layer of oil. When we boil the water, we remove any dissolved oxygen, and the layer of oil prevents any oxygen from further dissolving. In the last test tube, add a spoonful of calcium chloride. Calcium chloride removes moisture or water. So in the first test tube, the nail is exposed to oxygen and moisture. In the second test tube, the nail is exposed to oxygen, moisture, and salt. So in the third test tube, the nail is only exposed to water. In the fourth test tube, the nail is exposed only to oxygen. Stopper all 4 test tubes with a rubber bung and let stand for a couple of days. You will find that the nails in the first and second test tubes have rusted. In particular, the nail in the second test tube has rusted more than the nail in the first test tube, and the rust has likely flaked off. You may see a reddish-brown precipitate at the bottom of these tubes. The nails in the third and fourth test tubes have not rusted. So what has happened here? The iron has undergone an oxidation reaction, forming hydrated iron trioxide or rust. Salt and acid act as a catalyst for this reaction, which is why the nail in the second test tube formed more rust than the nail in the first test tube. Rusting can be very costly if we have to constantly replace these items made of iron and steel. Rust can be prevented if we paint the areas exposed to oxygen and moisture. This is done on many bicycles and cars. Another method to prevent rust is by placing a layer of oil or grease. This is done on many bicycle chains. It helps lubricate the moving parts, which reduces friction and slows down the rusting process. Another way to prevent rusting is a sacrificial protection method called galvanizing. Have a look at this reactivity table. Zinc is more reactive than iron. When exposed to oxygen and moisture, zinc will corrode faster than iron. So if we put them together, zinc protects iron but is sacrificing itself, hence the term sacrificial protection. This method is applied to prevent rusting on ships. The oxidation of zinc can be described using this following equation. So besides preventing rusting, there is another advantage to this galvanizing process. The formed zinc oxide layer can be removed, and the freshly exposed zinc can corrode once again, thereby further protecting the iron or steel hull.
Next concept is rancidity. When foodstuffs or oil remains for longer time, it gives foul odor. This process is called rancidity. If the food is cooked in such oil, its taste also changes. When oil or ghee is left aside for long time or fried food is left aside for long time, it undergoes air oxidation and becomes rancid. So due to rancidity, foul odor is coming from foodstuff or oil and its taste also changes. This rancidity can be prevented by 2 ways: by using airtight containers so that oxidation of foodstuffs will not take place, and use of antioxidants so that oxidation will not take place, as they are antioxidant, that is, they will oppose oxidation process.
Have you ever tasted or smelled the fat or oil containing food materials which have been left for a long time unused? These fats and oils which have been left for a long time unused get oxidized and become rancid. As a result, their smell and taste also changes. This process is called rancidity. Usually substances which prevent oxidation, also called as antioxidants, are added to foods containing fats and oil. Keeping food in airtight containers also helps in slowing down the process of oxidation. Do you know that chips manufacturers usually flush bags of chips with gases such as nitrogen so as to prevent the chips from getting oxidized?